hypotenuse, it didn't then matter which leg you called A and which leg you called B. So in this scenario, for this specific problem in number 2, our hypotenuse is always across from the right angle, so this time C is X. I will assign 5 as A and 12 as B. So we have A squared plus B squared equals C squared. So we are 5 squared plus 12 squared equals X squared. This is 25 plus 144 equals X squared. This is 169 equals X squared. Now we solve. To undo a square, we take the square root. And I had given you a little warning. I had said that number, when it comes to solving that 169, that's going to be a perfect square. And I think almost everybody recognized that 13 times 13 gives us that 169. So now we have X is equal to 13. Nothing's left inside the radical. How come I didn't write plus or minus 13? Because when we were just dealing with radicals and we were solving, we'd always write plus or minus. How come now I'm not writing plus or minus? Good, because a side length can't be negative. It could only be positive. So we immediately in our heads just reject that negative. Okay, so now, like I said, you guys have become Pythagorean theorem pros. But in the world of math, there are some Pythagorean theorems that are more popular than others. And these are called the Pythagorean triples. And instead of doing the Pythagorean theorem every single time on the more popular ones, what I want you to do is memorize the most popular ones, the ones that show up on the SATs, the ones that show up on the ACTs. You don't want to waste your time doing A squared plus B squared equals C squared every time for the ones that tend to show up a lot. So this is why we memorize these. I'm adding 2 more to the ones I want you to memorize. So the first Pythagorean triple is 3, 4, 5. In the list of numbers, I want you to recognize that the last number has to be the hypotenuse. So in 3, 4, 5, 5 has to be the hypotenuse. The next one is 5, 12, 13. That 13 has to be the hypotenuse. What about 7, 24, 25? Which number has to be the hypotenuse? 25. 8, 15, 17. 17 has to be the hypotenuse. 9, 40, 41. 41 has to be the hypotenuse. So these are 5 triples. Now, what I want us to do is add 2 more. But these 2 more that I'm adding are actually multiples of the first one. So if I take 3, 4, 5 and multiply all those numbers by 2, what do we end up getting? 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. So another one I want you to memorize is 6, 8, 10. There's one more that I want you to multiply, but it is another multiple. So if I do 3, 4, 5 times 2, I got 6, 8, 10. If I do 3, 4, 5 times 3, I'm going to get 9, 12, 15. And the hypotenuse has to be 10 and the hypotenuse has to be 15. So all together, I want you guys to memorize 1, 2, 3, 4, 5, 6, 7 Pythagorean triples. What do I mean when I say I want you to memorize them? If these numbers show up, I don't want you to do the Pythagorean theorem. I just want you to know the answer. And we're going to practice that today. So in this first one, it's 7 something 25. So I'm going to go back. I don't expect you to have it memorized yet, but I'm going to look at all the triples. Is there a triple that has one leg at 7 and the hypotenuse is 25? Yeah, this one right here. Isn't that 7, 24, 25? So now I double check. 25 has to be the hypotenuse. Is the hypotenuse 25 here? Yes. So that missing side without doing the Pythagorean theorem, I'm going to say is x equals 24. Once you memorize these triples, you're going to love it so much because it makes everything so much easier. It's not time consuming. And a lot of the times you realize that the problems are triples. All right, number 2. This is saying there's one leg that's 40 and the hypotenuse is 41. So I go back to my triples. Is there a triple where the hypotenuse is 41 and one of the legs is 40? Absolutely, the 9, 40, 41. So that missing side is 9. Now in number 3, I don't have the hypotenuse. I have one leg that's 8, the other leg is 15. So I go back to my triples and I'm like, oh, I found it. If one leg is 8, the other leg's 15, the hypotenuse has to be 17. All right, let's keep going. So now in number 4, I see a 3 and a 4. And in my head, I'm saying, oh, there's a 3, 4, 5 triple. Can somebody explain to me why this is not 5 for x? Noah? Good. Remember, I had said in the 3, 4, 5 triangle, the hypotenuse has to be 5. In this scenario, the hypotenuse is not 5. How do I identify the hypotenuse? What is it always across from? The right angle, right? Always across. Since that hypotenuse is not 5, this is not a triple. And if it's not a triple, then what do I have to do to get that answer? What we've been doing, which is the Pythagorean theorem. So it's not everything's going to be a triple. There's still times where we have to do the Pythagorean theorem. So I'm going to say 4 is C because it's right across from the right angle. I will say A is X and B is 3. So we're going to have A squared plus B squared equals C squared. So we're going to have X squared plus 3 squared equals 4 squared. X squared plus 9 equals 16. I'm going to subtract that 9 on both sides. And we're going to get x squared is equal to 7. And now we square root both sides. And I get x is equal to the square root of 7. There's no pairs in 7, so I stop there. Square root of 7 is very different than 5, right? Okay, I want to take a couple of minutes, and I know this is going to sound so silly, but I'm going to make you do this to help you memorize. So I'm going to give you a set of time in class to memorize. What I want you to do is write down on this sheet of paper, I want you to write down all 7 triples. Five times on this sheet of paper without trying, each time trying to do as many as you can without looking back. So I want you to write down all 7 triples 5 times, as many and each one write down as many as you can without looking back. And as you're writing it, say it to yourself. As you're writing it, say it to yourself. So try really hard not to look back. So maybe the first time, look back just to make sure you got it right. The second time, try to get one more. So what might be helpful is you write the first one. Actually, let's do it 7 times. We're going to do it 7 times since there's 7 triples. So don't worry, I'm giving you points for this in the grade book. So let's say you want to try to memorize, and we know the first one's 3, 4, 5. So if you write 3, 4, 5 7 times, by that 7 times, it should be in your head. The next one, you could do the multiple of 3, 4, 5. What's the first multiple of 3, 4, 5? We multiply by 2. Try to find ways to help you memorize. So we're writing each one down 7 times. And I know this is not the most fun, but I'm going to give you points for it. Easy points, right? Write stuff down. So there's 7 triples. There's 7 triples. We added 2 more to our list. There's 7 triples altogether. And we're writing down all the triples 7 times. And each time you're writing it down, say it to yourself. 3, 4, 5, 6, 8, 10, 9, 12, 15. It's not 17, 7, 24, 25. Okay, are you ready with 7 more times? As soon as you're done writing it the 7 times, write your name on it, raise your hand, give it to me so I can give you points. And we're going to look for this. Once I check it, I'm going to give it back to you. If I give it back to you, that means you got all your points. You're missing 60. Oh, yeah. Not 19, 9. Yes. Okay, Jack M, tell me any triple. Anyone you want. 3, 4, 5, love it. Bella, tell me any triple without looking. Perfect. Maya, tell me any triple without looking. Caitlin, tell me any triple without looking. That's not on the board. 5, 12, not 13. Very good. Jonah, tell me any triple without looking. We're missing 2. Who thinks they know the next one of the ones we're missing? Jackie. You got it. 9, 12, 15. It's the multiple of 3, 4, 5. And we're missing the last multiple of 3, 4, 5. Anybody? Stella? 6, 8, 10. Perfect. All right. Next class, we're going to have a do now quiz on these. I'm going to hand you an empty sheet of paper. I'm going to say, write down the 7 triples and then hand it back to me. And then that will be your do now quiz. All right. So let's keep going. So now we're going to add something else to the Pythagorean theorem. In certain scenarios, like number 6, would you want to do the Pythagorean theorem on a decimal? No, you wouldn't want to do the Pythagorean theorem on a decimal. So what we can do is we can take this triangle and multiply it or divide it to make it into a similar triangle to make our numbers easier. And I'll show you how to do that. So right now, number 5, 9 something 15. I hope you all recognize this as a triple and you're not trying to do the Pythagorean theorem. I have one leg is 9. I have the hypotenuse is 15. Which side is missing here? What number? 12. You got it. So x is equal to 12. All right, number 6. This is what we were just talking about. We do not want to do the Pythagorean theorem on a decimal if we don't have to. So I have to think about this 7.5. We could only multiply or divide. We can't add. So what can I multiply 7.5 by to get it to be a whole number and not a decimal anymore? So it's like, what can I multiply a half by to get it to be a whole number? 2, right? So what we're going to do is we're going to take this whole triangle and multiply the whole entire triangle by 2. So now we're creating a similar triangle. And when we multiply that whole entire triangle by 2, we get a new triangle. And 4 times 2 is 8. 7.5 times 2. Let's say you don't know how to do that in your head. It's okay. You do 7.5 times 2 over on the side of our paper. 2 times 5 is 10. Carry the 1. 2 times 7 is 14 plus 1 is 15. It is not 150. Remember, when you're multiplying decimals, because there's one number in total to the right of the decimal in this problem, we're going to make sure that there's one number in total to the right of the decimal in our answer. So our answer is 15.0. Do I need that 0.0? No, that's saying point nothing, right? So we don't need that 0.0. So that tells me that this side is 15. So now I have an 8 and a 15 and a missing side. This is another triple. Jack, C, tell me, what is the missing side in this triple? 8, 15?
8, 17.
8, 15, 17. You got it. 17 is not my answer. It's not my answer because from the original triangle, I enlarged it. I multiplied by 2. So now that I have my bigger triangle and I have that missing side is 17, I have to now go back to my original triangle. Well, if I multiplied by 2 to get to my new triangle, what do you think I have to do to get back to my old triangle? Divide by 2. And what we can do is just write 17 over 2 and leave it just like that as an improper fraction. If you wanted to write 8.5, would that be okay? Absolutely. Because we didn't want to do the Pythagorean theorem on 7.5. So we could only multiply or divide to create a similar triangle. So I had asked, what can I multiply 7.5 by to get it to be a whole number, not a decimal anymore? So if we multiply 7.5 by 2, that gives us a whole number, 15.
So like no other number can get it to like a whole number?
4, right? But we want the smallest number possible. So it's like what you look at the decimal a half. What is the smallest number I can multiply a half by to get it to be one whole? That would be 2.
Wait, but like what if you like multiply the thing by 2 and then it's not one of the triples? And
Then you do the Pythagorean theorem and then you'll divide back.
So-
You're going to see in the next one. Okay. So number 7, I don't know about you, but I would hate to do the Pythagorean theorem on 55 and 77. Can you imagine squaring those and then having to take a square root? It'd be miserable. So I don't want to do the Pythagorean theorem on 55 and 77. But in order to create a similar triangle, I can only multiply or divide. Do you think we're going to multiply here? No, that's going to make numbers even bigger. What can I divide by? So what number divides evenly into 55 and 77? 11. So we're going to take this whole triangle and divide it by 11. And so when we take this whole triangle and divide it by 11, I'm going to get 55 divided by 11 is 5. 77 divided by 11 is 7. And then I have 5 something 7. Do we all agree? 7 is our hypotenuse. This is not a triple. 5 something 7, there's our triples up there, right? This is not a triple. So when it's not a triple, what do we have to do? Do the Pythagorean theorem. So now I can't call this missing side x. I'm going to call it y because I've already used x and this is not the same as x. So now for my Pythagorean theorem, I'm going to get y squared plus 5 squared equals 7 squared. Everybody okay with how I set up that Pythagorean theorem? All right, so now this is y squared plus 25 equals 49. I'm going to subtract the 25. So we get y squared is equal to 24 square root. Now 24 I could break down. So 24, I'm going to say 6 and 4. 4, I'm going to say 2 and 2. There's no point in breaking down that 6 because I can't get any more pairs. So we're going to end up with y is equal to 2 root 6. This is not my answer. So most of the time, students get this far. They do all the hard work. They get the right answer for y. And then because they're in a rush and they're not focused, they just stop. You're not done because this was not my original triangle. I have to divide by 11 to make this triangle. So now to go back to get my answer, what do I have to do? Multiply by 11. So I'm going to go back, multiply by 11. And so I'm going to have 2 root 6 times 11. This 11 is a whole number. So it just gets multiplied with the whole number in the radical. So this becomes 22 root 6 is our missing side. So we're definitely stepping it up, right? Adding different elements in here. All right, more practice. Number 8. Do you want to do the Pythagorean theorem on 30 and 34? No. So we want to now make a smaller triangle. What number divides evenly into 30 and 34? They're even numbers. So what? 2. Exactly. 2 always divides into even numbers. So I'm going to divide by 2. 30 divided by 2 is 15. 34 divided by 2 is 17. This is a triple. What is this triple? Something 15, 17. 8, good. 8, 15, 17. But now this is not my answer because I divided by 2. To go back, what should I do? Multiply by 2. So what is x going to be? 16. All right, I want you guys to try number 9 on your own. You guys try number 9 on your own.
Good job, Jen.
Oh, no Pythagorean theorem. Always look to see if it's what.
Oh,
Guys, always check yourself to see if it's a triple.
so that's. Yeah. What do you do? Oh, you're dividing by 2, okay. Yeah, that's 24, down 7. So that is a triple. 7, 24. But that's not my answer. I divided by 2, now we have to go back. So that's why, okay, so we don't forget that's how I show that I'm dividing by 2. I make a new triangle and I go back multiply by 2. Do that for me so I can at least give you partial credit if something goes wrong.
You gotta watch it. You gotta watch it. Everybody sees the math and the weapon.
What's that last side? 17. Right, now you go back and you
This one, but. It's, you knew this, but yes, we. That's.
So we're almost
That's all I understand anything with your-
too.
Yeah.
Swearing it.
Teach us. Yes, and yours, memorize. That's what she's saying. That's all you need.
So like, if it was like a 9, 12, 15 and you reduced it, it's fine, just as long as you multiply it. All right, guys. I walked around, everybody got it. We got x is equal to 50. It ended up being, when you divided by 2, a 7, 24, 25. We went back, multiplied by 2, got us 50. Okay, so now number 10. Do you see how the outside numbers are a triple? There's a 9 and there's a 40. And so what would be the triple? 9, 40, what? 41. It'd be the triple 9, 40, 41. You want to make sure they have the same radical with them. Do they have the same radical? Yes. As long as they have the same radical with it, you can follow that triple and just say 41 root 2. Because essentially what's happened here is they just took the 9, 40, 41 and multiplied it by the square root of 2. That's all they're doing. So we can stick with that. Now, if it was 9 root 2 and the other one was 40 root 3, would that be the triple? No, because they have different radicals. So that wouldn't work. Pythagorean theorem, but I would never give you numbers that big if I needed you to do the Pythagorean theorem. There's one more I want to add in here. Just draw it right underneath of it. So I wrote square root of 3, square root of 4. Guys, this is not a triple. The last one is not the square root of 5. Because 3 and 4, aren't those numbers very different than the square root of 3 and the square root of 4? Right? So once I put the radical over it and it's not like a pattern like in the first part of number 10, right, you have to do the Pythagorean theorem. So if we were doing this here and we had to do the Pythagorean theorem, it would be the square root of 3 squared plus the square root of 4 squared
equals x squared. The square root of 3 squared is 3. The square root of 4 squared is 4 equals x squared. Because remember, guys, root 3 times root 3 is the square root of 9, and that becomes 3 and 3, right? And the same thing, square root of 4 times square root of 4 is the square root of 16. That becomes 4 and 4. So you pull out the 4. Yes, or am I going too fast? We're okay? All right, so then we would have 7 equals x squared, square root both sides, and we get x is equal to the square root of 7. All right, number 11. I actually want you guys to try number 11 on your own. Try number 11 on your own. You don't want to do the Pythagorean theorem with a decimal. Since you don't want to do a Pythagorean theorem with a 0.5, what would you multiply 0.5 by to get it to be a whole number? 2, exactly. So always multiply 0.5 by 2, and that will get it to be a whole number. Good. You could just leave it as an improper fraction. You could just leave it 5 over 2. And then you're perfect. We'll just leave it just like that. When you multiply 6 by 2, that's 12. That's good. 6.5 times 2. 25 and 0 carry the 1, right? So it shouldn't be 12, it should be 30. This is a triple, yeah. Yeah. Let's see. Good. Perfect. Perfect. Okay, so you multiply by 2, right? So we get here. So now to go back, you're not multiplying by 2. You're multiplying by 2 to get to this. That's why I always want you to write what you're doing. So you're multiplying by 2. Now to go back, you're not going to multiply by 2. You're going to divide. And then 5 divided by 2.
Like the first game.
You could write it as 5 over 2, or you can change it to a decimal if you want.
Maybe back.
Yeah. Perfect. All right, I think I checked everybody. So what we should have done is multiplied by 2 to get rid of that decimal. And when we multiplied by 2, we got a 12 and a 13. So this is a triple, 5, 12, 13. So now what we're going to do is go back and divide by 2. So I would have just left it as 5 over 2. If you wrote 2.5, equally as perfect. Okay, for number 12, and I believe this is actually where we're probably going to stop for today, which means you won't have homework except to study the triples, because what's going to happen on Monday? A do now quiz.
No computers, nothing. I'm going to hand you a piece of paper. I'm going to ask you to write down the 7 triples. Okay. So that's your only homework, is to study for that do now quiz. But no, don't pack up. We're going to do this last problem. So right now, this is not a triple, right? 16, 18 root 3, not a triple. I can't get rid of the root 3 because it's there and the other one doesn't have a root 3. So it's not going to help us. So what I'm going to do though is that I still think 18 is a pretty big number. So I realize I can divide by 6. So what I'm going to do is I'm going to make a new smaller triangle by dividing by 6. And when I divide by 6, 6 divided by 6 is 1. 18 root 3 divided by 6 is just 3 root 3, because 18 divided by 6 is 3. So that's just 3 root 3, and then a y. So now I use the Pythagorean theorem. I have 1 squared plus 3 root 3 squared equals y squared. So 1 squared is just 1 times 1, which is 1. Now 3 root 3 squared is 3 root 3 times 3 root 3. So we have 1 plus, and then multiply the outside numbers. 3 times 3 is 9. Multiply the inside numbers. Root 3 times root 3 is root 9. And now we simplify this. 9 gets broke down to 3 and 3. There's your pair. So it comes on the outside, but there's already a 9 on the outside. So what do I do with that 1, 3, and the 9? You multiply them. So 1 plus 27 equals y squared. 28 equals y squared. Now we square root. I'm going to bring it over here because I'm running out of space. So now I have the square root of 28 equals y. I'm going to break this down into 4 and 7. 4 becomes 2 and 2. So we end up with y equals 2 root 7. This is not my answer. This is y equals 2 root 7. What do I have to do to get back to my answer? Jay? Multiply by 6, because we divided by 6. Now we have to multiply by 6. So I have 6 times 2 root 7 is 12 root 7. That is my missing side. All right, guys, this is where we're going to stop. We'll finish up this lesson next class.